Okay, John beat me to it. Excellent. Hello, everyone. My name is Josh Persi. Today we're going through chapter 19 of Advanced R. This chapter is all about quasi-quotation. I'm going to my slides right now. And this was a bit of a whirlwind for me. Learned lots, so yay for book clubs, but I may struggle to articulate some of the things. I may misuse terms. Correct me as often as you can and jump in with your own thoughts and takeaways from the chapter. So I've also modified the slides a little bit from last year's. I'm not sure if they're a net improvement, but if they're not, we can roll back those changes. But this is just being hosted on my local machine right now. I have yet to push these to the repo. So today, by the end of today's session, I hope you will understand the meaning of quotation, unquotation, and quasi-quotation, and the importance of quasi-quotation to tidy evaluation or tidy eval. Quasi-quotation is it's something I struggle to define in a nice name, like is it a behavior, a feature, technique? But it's kind of all of those things, it seems to me. But it is central to tidy evaluation, as you probably have experienced it using the tidyverse if you have. Quasi-quotation is one of three pillars of tidy eval. The other two, data masks and closures, are the focus, I believe, of the next chapter, chapter 20. But we'll talk about them a bit here since they're all kind of jumbled up together in my mind, at least. And what quasi-quotation does is it allows for evaluation of select parts of an expression. Expressions were covered last week by Nick. And this makes it super easy, well, not super easy, but easier to combine if you are a developer or you're writing a function for others to use. It makes it easy to combine your code that you've written as the developer with user-provided arguments to make certain data processing, data analysis, data tasks easier. And this pops up a lot in kind of the tidyverse, so much so that I didn't at least understand how widespreadly it was being used. Quasi-quotation is a catch-all term, or is a broader term that encompasses two separate components, quotation and unquotation. And quasi-quotation is a feature of base R, but to my mind, it was really popularized by the tidyverse. It doesn't seem like unquotation was something that was widely done in base R, but it seems to be quite commonly used in the tidyverse. So that's maybe a little wall of texty. We'll dive into some examples in Positron, a code editor, right now. So we're going to show this code in Positron, which you should all be seeing now. Can I get a head nod? Yeah, okay, perfect. Perfect. So we'll walk through some of this, hopefully to make it clearer what's happening. I'm going to talk about minimap. So we're going to use rlang, a tidyverse package for many utilities, I would say, but it does have a lot of stuff for a lot of functions for quoting and unquoting and dealing with expressions. Let's first consider this function, paste from base. It does not quote its arguments. So its arguments are good, morning, and Hadley. Those are the arguments. I'm just going to double check the chat in case anyone has. Okay, sounds good. Feel free to, if you do have a question in chat, feel feel free to use the chat or just hop on the mic. So these arguments are unquoted. And I say that because let me start with this example. This function, as you might have done it, you're passing in strings as arguments. It returns text, no problem. If you try and pass in a thing that is not a string, here we're passing in good without the quotation marks, and we'll get an error because good is not found in my global environment. So it's what paste is doing is it's evaluating good as an object, but because good is not defined, it is returning an error. And this is unquoted behavior. What quoting does, and quoting is also called diffusion, as in diffusing a bomb, that Nick talked about last week, and the Erlang documentation seems to use that terminology quite heavily in lieu of quoting. But what quoting could do, it will be shown by this cement function. So this cement function is just a function we're creating where we're quoting the things that we're passing through the dots using a particular function from Erlang called nsims, which we'll touch on later. And then we're just basically concatenating those quoted arguments. So we'll create that function. And now what we can do, even though, if I just copy this over here, even though good, morning, and Hadley do not exist as objects in my environment, we can pass this. Those arguments are captured or quoted or diffused, meaning they are not like immediately evaluated as our objects. And we could do whatever we want in our function with them. In this simple function cement, we're just converting them to characters as strings and printing them back to the user. So that's an example of a quoted function. Just going to go back to these slides, make sure I'm okay. And maybe the last thing to cover for this introductory part is if we want to, say, have a variable for name and time, if we pass these objects or these arguments, which are now objects, time and name are objects in my environment, if we pass them to a quoting function, they will get quoted and the output will, oh, that should be cement, excuse me. So if we use our quoting function, we will get time and name are not evaluated, and they're just getting processed as per the logic in the cement function here. So which is just to print them back as strings. If we want to inject or unquote or tell R to evaluate this as an R object, we need to use something that we'll touch on a little bit later called the bang bang or unquote operator or double bang. This tells the function cement that we want to evaluate this argument as, we want to take this argument that has been quoted as an expression and evaluate it. And then we get the predicted output. That is a fairly contrived and not super interesting example. But I think the takeaway here is that like across the whole tidyverse, Quasiquotation makes for simpler UI, user interface, so that you as a user don't need to say wrap everything in quotes and like pollute your scripts with a bunch of quotes. You can usually just write the names of columns, for example. But that's also wrapped up, at least in my brain, with ideas of like data masking, which are the focus of next chapter. So I will continue on from here. Again, jump in with any questions or comments or corrections. So quoting captures code as expressions. If you are just writing for yourself in an interactive session, rlang has several functions you can use, and it's kind of a dizzying matrix of functions to keep in mind. You have these first three: expression, which captures the code as a expression, which is, I think, the least strict of these three options. We have sim, short for symbol, which captures the code as a symbol, where a symbol is the name of an object. So it has some more strict, it's more strict in the sense that it expects basically a string of length 1 that is converted to a symbol. So you couldn't pass like a list or a vector of length greater than 1 to sim. And quo isn't talked about, but is also a quoting function that creates a quosure. And in my previous attempts at using quasiquotation, I have basically slotted in all three of these functions in my own functions to see what worked. And quo was one of the ones that would trip me up. So I've included here just for completeness. But those are just, these three, the top three, are just if you have like a single, I'm going to use the term object loosely because I don't know if it's technically the right word to use, but if you're trying to quote or capture a single thing, where that thing could be like a lengthy expression or a symbol or a quosure. If you want to capture multiples, you have the same symmetry. Well, you have symmetry with your single object versions. You just add an S to the end to pluralize them. But these are all just for an interactive session. You are using them yourself. You are not writing a function to take user input and do stuff with it. And where I say input, I mean an argument. From within a function call, so if you are now the developer or programmer writing, an author writing a function for use by someone else, you would use these same set of functions, but you would prefix all of them with en. And the book mentions that en here is remembered by or used to refer to this idea of enrichment, where you're taking a user-specified argument within your function signature that you're writing, and it takes that user-specified argument and it enriches it by turning it into an expression, aka by quoting it. Not sure if that's helpful, but that's how I am trying to understand that part of the book. So far we've been talking about quoting, which is the act of diffusing or capturing or telling R to not evaluate that right now, evaluate that bit of code right now. As far as I understand, base R offers a lot of quoting functionality, but what it doesn't offer as much of is unquoting. I'll start at the bottom of the slide. In base R, it sounds like, strictly speaking, unquoting is only available with bquote, but is not regularly used because bquote has some limitations. But there are other ways of kind of doing unquoting. I think with the substitute function from base R that, as far as I understand, are not strictly speaking unquoting. They might be evaluation or some other term, but I think the end result is very similar. But I'm not as familiar with those, and the book at least has some cautious caveats around the use of bquote. So We'll talk more about the rlang ways to unquote, which are mentioned up here. So in rlang, the package, if you are using other components from rlang like sims, quos, nsim, and exps, and expers, you can unquote or evaluate the expression or the symbol or the closure that has been captured using one of two operators. And these just address a different number of arguments. So if you have a single argument, you can use bang bang, the unquote operator, double bang. Those are all synonyms for this. And if you have to unquote multiple arguments, you can use bang bang bang, triple bang. This is also called the unquote splice operator. These are really used as unquoting operators when you're in like an rlang workflow, an rlang context. There are some caveats around using these outside of an rlang context because they are kind of a weird operator in the sense that I think rlang sees them differently. But if you're not using rlang to see them, they are just getting interpreted by R as like the negation operator. So not, or not, which can lead to all sorts of weird behaviors if you're expecting it to unquote, but really it's doing some form of negation. Um, let me go back to my editor for a second. Let me see if there's anything interesting here. I don't have the slides end in maybe one or two slides. So maybe I'll go back to something I wanted to do a bit earlier, which is cover some of the basic examples from the book. I've just copied them here into the editor. For each function in the following base R code, identify which arguments are quoted and which are evaluated, i.e. the function is not a quoting function. I'm just going to grab a sip of water. Oops. So library mass, the library function that's calling the package mass. This function is quoting the argument mass. And one way the book mentions we can figure that out is if we type the argument just in base R, just in the R console, and it returns object not found. It's probably a good sign that this is a quoting function because it's taking what we're passing to it, mass, and doing something with it. In this case, whatever the library function is doing to load it into our current environment or our current session. You can get into some odd behavior where I think one of these function parameters changes whether this function uses quotation, is a quoting function or a non-quoting function, but I don't know much about it, and I think it's kind of an oddity, but maybe we can keep going. So, okay, great. Chat message. Character, yes, I think you're right, but Martine, that it's character only. But if I do library mass, will this fail? Yes, it will. So I guess in this case, I would need to, I guess if I hit character only true, it is no longer quoting. and I need to pass like a string literal. Yeah, okay. So weird behavior. I'm not sure. Maybe if I was passing like a list of package names and then iterating across that, I would do that, but we'll leave that there. Okay, so in this example, empty cars 2 is a subset of empty cars where the cylinder column, the value in the cylinder column is equal to 4. Empty cars is a unquoted object, I believe, because empty cars exists in my global environment, in your global environment too, most likely, whereas sil is quoted because it does not exist. And I think this also might be related to data masking because somehow sil, the subset function, needs to know where sil is within the empty cars object. And if we run that to get empty cars 2 into our environment, we now have empty cars 2. And with this call, the with empty cars 2 sum versus, same idea, empty cars 2 exists versus, I guess it's not versus, it's, I don't know what the VS stands for in car lingo. But whatever it does not exist in my global environment. So yeah, okay. Maybe I'll skip the rest unless folks are super interested. I'm not sure if I'm doing a great job or an incredibly bad job because I see a lot of confused faces. So if anyone has questions and wants to help clarify, I think that would be great.
You're explaining really well.
Okay.
Yeah,
Okay.
I think so.
Some of the language or terms could be confusing, but I think you're defining them and a good job. Yeah, because
Okay.
diffusing and quoting, same thing. They came across really well. So
Mhm. Okay.
yeah,
Well, thanks for
Yeah,
the kind words, folks.
yeah,
and I think these examples are really useful.
Okay, great. Then we'll go through
Yeah,
them
like
at the very least because I probably don't have enough slides to take up the full hour. So okay. So now we're at some empty cars 2 a.m. So and this is another idea that is kind of tossed around in my head, non-standard evaluation. If you need a refresher, non-standard evaluation is where we can access, as an example, is where we can access, say, a column name from a database, from a data frame, even though that column doesn't exist in our local environment. For example, an example of non-standard evaluation, I think would be, let's do, actually, I'm not sure if I have dplyr in, so we'll do count empty cars AM, where the AM argument doesn't actually exist in my local environment, because if I hit AM, nothing comes back. But empty cars does exist in my local environment. If I wanted to do that get the same output as standard with a standard evaluation, I would need to use, well, I could use the same function. Maybe we'll do that. I could do something like this, where I'm specifying in a more standard way where AM lives within the empty cars dataset. But because of tidy evaluation, we don't need to do that. Makes our life easier. So anyway, so this example, sum empty cars 2 AM is a non-quoting function because empty cars 2 AM is evaluated and empty cars 2 AM exists according to my R console. Like it's an object that can be reached from my R console. Similarly, remove empty cars 2 is a, I feel like this might be a trick. I actually haven't looked at the answers for this, so I might be telling you falsehoods, but I'm gonna naively guess that this is a non-quoting function. Is it? Because we're trying to remove the symbol. I'm really not sure. I'm not sure what's going on there. Maybe we can go take a look real quick at the exercise solutions for. I'm just scanning, so let me know if you see it first. Where is it? So it is quoted. That's interesting. Because the book mentions. What I was trying to say about can you enter it just in your, a good way to see if a function is quoting or not is to try to run the argument outside of that function. And this example was provided, but it seems like that just might be a useful rule of thumb, heuristic guideline. And to really know, you would have to go check out the source code for that function. At least that's my quick reading of the exercise answers. Anyone else who has a different reading of it, please let me know. Okay, for each function in the following tidyverse, we'll just do the second set of examples and then we'll go back to the slides to wrap up. For each function in the following tidyverse code, identify which arguments are quoted and which are evaluated, i.e. passed to a non-quoting function. We'll pull those in. Empty cars is not quoted. SIL is quoted and MPG are also quoted. And the reason I'm saying that is because empty cars, again, through that, I guess, heuristic of can I enter it in my console and find it? Empty cars can be found, SIL cannot be found, and MPG, oh, I guess there's another data set called MPG. That's interesting. Maybe this gets at some like closure thing within Summarize where it knows where MPG is coming from. The empty cars data set, not my local environment. Yeah, let's go back and oh, that's the actual book. Those are my slides. Here we go. So it is quoted. But my best reading of this is it is using some sort of data mask, which we haven't covered yet, but we'll talk about in chapter 2, in chapter 20, excuse me, that tells Summarize in data masking ways that like, I think it might look something like this, that we use like I'm not very familiar with data masking, so I'll try to keep this short, but I think it would do something like that, where your like summarizes under the hood passing a data pronoun to tell the mean function that we're talking about, the MPG column within the data that we passed, which is empty cars, not the MPG data set that exists within as like a promise in our local environment. Stay tuned for chapter 20 next week, I guess, to talk about that.
Is that data mask object like an S7 object or a class from the
I
answers?
do not know. I am very unfamiliar with S7.
6.
The S3 dispatch, I don't know if that's helpful to you.
Well, yeah, I see S3 dispatch was summarized, but in the summarize calls function, there's data mask $ new. So it's either R6 or S7.
Okay. Okay.
Interesting.
It's not a S7 didn't exist when this book was written.
Oh, so it
Okay.
is R6.
I think it's a list. Or I guess it had $ new. Yeah. So where are we? Then that would be R6. I don't or something else. Let's see. Looking at because like I don't think dplyr uses R6.
Yeah, that's surprising to me actually.
Oh, it does. Huh.
Oh,
I don't think I ever realized that.
news to me.
They keep it all under the hood.
Hey Josh,
Yep, please.
if you put the n pronoun before the MPG, probably it's going to explode, right? Because it's going
Yeah,
to
that's
think that you want to use the
Yeah.
data set.
yeah. In group
Okay,
one.
it's not it's kind of exploding, but
Yeah, definitely not a smoothly returning function there,
Mm.
but just for anyone who's not familiar with that pronoun, I think that's just another pronoun, one of two, I think, dot data dot env that tidy eval uses to direct where the thing on the right side of the $ typically the
yeah,
column, the object is
exactly.
being evaluated or being pulled from. Okay, so we'll put that. So in this case, by sil is not being quoted, I don't believe, but the arguments within aesthetics AES are being quoted, and probably data masked. Like I would say, almost certainly data masked under the hood. So maybe just with this example, like it's tidy eval makes all that relatively easy. And quasi-quotation is one of the pillars of tidy eval. So kind of ipso facto, it's good to know. But you don't need to know quasi-quotation if you, like, I guess quasi-quotation and knowing how it works is really a value if you're writing tools or functions for other people, it seems like. If you're just using like dplyr, ggplot, and tidyr to like explore your data, make a summary, and plot it, quasi-quotation might not be the first tool you want to reach for. And I think this is like a bit before my time being involved in the community, but I think there was like some sort of like now lost to me long-standing thread of people saying you don't need to use quasi-quotation for this. Like there are other base R, or not base R, but like other simpler tools to use. I should try and find that thread, but yeah, maybe just like don't reach for it eagerly. There might be other easier ways to do things, but it's definitely cool to know.
Well, in the functions chapter from the R for data science, they recommend using the new embrace operator. I mean, this is like
Yes.
for more, I don't know, complicated cases. Like
Yeah.
Quasiquotation.
And for anyone who is watching this on YouTube and doesn't know what the embrace operator is, it's basically a replacement for bang bang sim something. You would just write something like that. So it's just like a shorthand for functionality introduced by Erlang. Just seeing the messages. Yes, Stas will be talking about evaluation next week, where we get to learn about data masking and closures and all that, I believe. Okay, to wrap up, I think my last two slides, and then happy to have a general discussion on any points that I overlooked from the book. You can use triple bang outside of an R-line context as basically argument expansion or argument unpacking, if you're familiar with that term from Python or other languages. But if you aren't, I'll explain it. What this allows you to do is if you see a function that takes ... the ellipses ... that means that that function accepts an arbitrary number of inputs, an arbitrary number of arguments to it. And if you could specify each of those arguments manually by writing each out in the function call specifically. But if you have already a list, if you have a list in your workflow and you want to just pass that list and say, hey, function, take this list and expand all of its contents as arguments to be used by the function, that's basically what the bang, bang, bang operator lets you do. So for example, rbind from base R takes ... and it allows any number of data frames or other objects, I believe, to basically be stacked one on top of the other. So it works for 2, it works for 3, it works for 4. If you have a big list of data frames that you want stacked together, it would be annoying to write rbind data frame 1, comma, data frame 2, comma, data frame 3, comma. But what you can do is this, you can use the triple bang operator which is called the unquote or splice operator or the triple bang operator. And you are basically, I think of it as exploding, unpacking, expanding. I guess any of those verbs could work here. You're taking the arguments or the elements of the list that is called data frames, where we just have empty cars, empty cars, empty cars. And we're basically putting those, it's as if we had written those out as separate arguments because of the triple bang operator. It's expanding them. So like a useful little thing there. Does it not work with rbind? Maybe I have misled you. Thanks, John. Let me go try that right now. All right, so we'll just make it data frames. So for everyone's benefit, this is what data frames looks like, just a list with 3 data frames. And now I thought this worked. Oh, it does not. I must have tried it with
Maybe
rows.
that is a deployer version.
Okay.
Yeah,
Yes. Yeah, which is the version I use more than rbind. And I think this has something to do with what the book called or introduced as tidy dots. But I assume tidy dots are used in many places throughout the tidyverse, but I don't really understand how they're different
So
than
what I
just ...
what I read, it seems like the only difference is that you use rlang list 2, so that if you had like a trailing comma, it kind of swallows that up. So it
Mhm.
doesn't really matter, but that was my interpretation of like the only difference.
Okay. Um, I think I remember reading that too. I wish I knew more. Like, why does list two do that? Other than just like the fact that it's list two.
It probably just has some logic where like if the thing is empty or missing, like it just omits it and then returns it back.
Okay.
I
Okay.
don't know. I haven't looked at it.
Okay. I'll so this slide should say find rows, but useful to know if you need to unpack a list of arguments to a function that uses tidy dots, which I'm assuming is mostly a tidyverse, a function from the tidyverse. I don't know if this functionality would work for base R functions.
Mhm.
The last thing for me to talk about are expressions, which was obviously a mistypo typo for expressions. But yes, expressions. The operator that looks like this, I call it the walrus operator because it looks like a walrus with tusks. But the book calls it, I think, the colon operator. What it does is it allows the thing on the left side of equal sign to also be an expression as opposed to like a symbol-esque name of things, name of a thing. So what you can do with this is, oops, that should be, let me just pull this out and I'll do this in code and then I'll fix these slides. If you have var and value, if you wanted to do this, it should not work, I believe. Yes, because it's telling us there's a syntax error because this left side is being treated as a unquoted expression, which is verboten if you are using the standard equal sign. But if you use the handy dandy walrus operator, I think this should work. Yes. So the walrus operator allows for some funkier expressions to be on the left side, which allows you to use the unquote operator bang bang to inject column names in a tibble call, in a mutate call, like if you're doing some programming, meta programming with dplyr functions, as I have noodled around with. This can be useful if you're trying to inject a quoted argument as a column name in some outputted data frame. Okay, that is everything I had. Um, I am, oh, not bad on time, 10:40, 10:47 Pacific time. So um, we could end it there. I can free you from my ramblings. I hope that was somewhat valuable to all of you. If you have other questions, comments, concerns, now is your chance to voice them. Otherwise, I think we can wrap up.
So my only comment, I'm just thinking about the chapter I presented last week. So expressions, they're not one of the like you're the quasiquotations, like the first pillar on tidy eval. Expressions are the things, are the nouns. The nouns where quasiquotation supplies the verbs. I don't know. I
Yeah,
think I might be butchering that.
At least in like initially without thinking about it too much, I think that makes sense. Because I think regardless of whether you're like using an R-line function like nexpr or nquo or nsim,
Yeah.
they're all kind of expressions to my mind, just maybe a specific type of expression, where like a symbol I think is a kind of expression, just a like length one character type of expression. So that distinction makes sense to me, Nick.
Hmm.
I think I have like a comment. I don't know. I've been reading like about metaprogramming science a while ago, like reading the Erlang docs and those stuff. And I think it's difficult because it's a lot of new like language or jargon. I don't know, like a lot of new concepts, and some of them are really like similar between each other. But it's that one time that you find a problem that can be solved with Erlang or metaprogramming. It's like, oh, this is useful, nice.
Yeah.
I put an example in the chat, but I don't know. I just wanted to say that. But I don't know if in my experience there has been a lot of use cases, but there was like a I don't know, 3, 4, but it was a really nice solution. It was. So I'm glad that I studied this. I read about this. So yeah,
Awesome. Awesome. Thanks, Martin. Okay.
and thank you for the presentation. Well, I
Yeah,
think it was
thank
really
you.
good.
I hope it was somewhat
Yeah.
cogent.
Yeah,
It was tough for me to get my head around.
All right. Well, thank you very much. And yes, we will see Stas next week.
Sounds good.
Thank you.
Thanks, everyone.
Thank you.